9 ground-based monitors, which is the basis of this validation. So, we can't really say with only 9 ground locations how well this might generalize for the whole continent, but that was the best we could do at the time. So for accessing the data, there's a couple different ways to do this, but I think the most user-friendly is probably the fluid system. I have the link on the slides here, and hopefully you'll have access to the slides after the presentation. But the fluid system is basically our system for visualizing outputs of the model. So for example, you can go to the system and bring up a specific relevant quantity. In the upper left there, you can see, for example, PM 2.5. You can bring up a region of interest, and it will show sort of a pre-generated plot of the average concentration for the specific date and time of that constituent. And you can also create an animation of the 5-day forecast, which is what's being shown here for a specific forecast, the animation of that. There's also a more interactive version of this where you can kind of zoom and pan on the map and pick a specific location of interest and bring up, for example, the forecast for that specific location in terms of PM 2.5, which is what's being shown here. So that's ways to access and use this global model information for air quality applications. And then finally, I wanted to talk about combining all these data sets I talked about. So the satellites, the models, and the ground-based data. And there's a couple different broad approaches you can use which might go about for this. One approach, which is being implemented by the World Resources Institute with their Canary Alert system, is to combine the model and the ground-based data. So in this case, they're using the forecasts from the GOCF system, which I just talked about, and they're combining that with local data from their specific partner locations. In this particular example, it was the AirQuo low-cost sensor network in Kampala, Uganda. And based on historical data records, comparing the estimates of the model in the past to those past measurements at the ground stations, if you'll recall in the example from carbon monoxide from Malawi, there could be disagreements between the model and the actual measurements on the ground because of the mismatch in size. For example, the model is representing the average over a specific grid cell of the model, whereas the monitors representing concentrations at a very specific location. But by looking at the past relationship between these two, we can use machine learning techniques in this example to learn what that relationship is between the model and the ground-based measurement, and then apply that same relationship to the forecasts of the model to infer, what the specific concentrations at that location might be in the future. And that's what this system is basically doing. So that's one approach. Another approach, which is what I'm doing in a project that I'm involved with, is we're trying to bring the local data from ground-based monitors, both regulatory monitors where they're available and low-cost sensors, together with the GOCF model and then relevant satellite data to create a merged estimate using the Google Earth Engine the Google Earth Engine platform as our data analysis platform to make it a little bit more accessible and usable by people who have experience with that platform, and use that to do our data fusion. So what this might look like, this is an example of the prototype that we're working on now, is we use the basic estimates from the model at its spatial resolution. Then we use the satellite data and the satellites taking measurements, and we can use the model to inform us about what the relationship is between the column concentration, which is what the satellite's looking at, and the surface concentration, which is what we actually care about. The model is simulating both, so it can tell us about what the relationship between those quantities might be. We have the column concentration from the satellite, and then we use that relationship from the model to infer what the surface level might be. And then finally, we can look at how well that actually agrees with any monitoring data we have in that area, for example, from regulatory monitors or from a low-cost sensor network, if that's what's available. And we can use that to kind of tweak or update our relationship based on that agreement, similarly to what I talked about with the WRI example, where they're looking at the historical relationships between a model and the surface data and extrapolating those into the future. we can do kind of the same thing here, where we look at the historical relationships now between the model and the satellite combined versus the ground-based data, and then extrapolate those into the future to inform our forecast. So that's the general idea here. Again, this is still a work in progress, but we hope that by developing this kind of a system and implementing it in a platform like Google Earth Engine, it will make the system a little bit more accessible to people in the future. So for the last couple minutes here, I'm going to talk and briefly introduce some resources for data analysis, and then places to go to learn more, because I know this was a very sort of quick overview of a lot of different topics, and I wasn't able to go into depth about many of them. So the first thing I want to introduce was NASA Worldview, and this is, you can see the link at the top there. Again, you should have access to the slides to take a look at this on your own. But this is really a tool for fairly easily visualizing different satellite data products. For example, here I've brought up the MIAC aerosol optical depth data product, which I mentioned, and I'm just visualizing, the MIAC data product for a specific day using the slider at the bottom to select my time, and then navigating as you would in any kind of map software or map app to a specific location. So this is, again, just a pretty easy, straightforward to use user interface for just bringing up and visualizing satellite data products. If you want to do a little bit more analysis, another resource is NASA Giovanni, and this is a web-based tool for doing analysis on the level 3 and level 4 data products. Again, those are the gridded data products where the data has been placed on more of a uniform grid. And you can do several basic analyses with these types of data. For example, in the figure here, I've told it to take the average of concentrations of NO2 from the OMI level 3 data product and average the concentrations for every, for January from 2005 to 2020. So this is the month of January average across all those years for West Africa, basically. And I'm showing the plot of that here. So the advantage here is that you don't actually have to download the data yourself. You just go to the website, you follow the user interface to pick your analysis region, to decide what kind of plot you want to create, whether it's a map like this or a scatter plot or a time series plot. And it'll do the analysis online without you having to sort of access and download the data yourself. And if you did want to access and download this data yourself to do a more in-depth analysis, the recommended tool there is the Earth Data Search. Here you can basically pick your location or area of interest, time of interest, and your data product, and it will go through and filter and select all the relevant data granules, basically all the relevant files for that data product, for that area, and for that time, and give you some tools or some shortcuts or some pre-generated scripts to download those data for yourself. And then finally, training resources. So the first one I wanted to point out was the NASA Applied Remote Sensing Training Program. This is basically a service that creates and provides and delivers trainings in how to use satellite NASA data in general, but more specifically, satellite data for a variety of application areas, which are listed on the right. You can see health and air quality is one of those application areas. So I'd say this is a very good resource to go to if you want to learn more about using satellite data and you want to start using satellite data for these specific types of applications. Most of the trainings, at least especially in recent years, are online trainings, and those trainings have been recorded, so you can go back and watch previous trainings as well as sign up for future trainings. And this slide is, for your future reference. It has links to a couple of the trainings which I think might be interesting and useful. At the top there's a course on the fundamentals of remote sensing. I tried to go through that very quickly at the very beginning of this lecture, what the fundamental concepts are, but that is a more in-depth course, and it's being developed into a full sort of self-paced interactive online course that you can take. Moving on from there, there's a couple other introductory level courses which talk broadly about measuring air pollution from space or applying machine learning concepts to earth science. That was a very popular recent course. There's also more intermediate level courses, which go more into more specific detail about different types of instruments. For example, there's one on use of satellites for fire risk detection and analysis. I very briefly mentioned that the satellites provide fire detection information. That course would go into a lot more detail about that. There's also accessing and analyzing air quality data from geostationary satellites. So again, I very briefly mentioned the Meteosat geostationary satellite data set. If you want to learn more about that and its capabilities, you can take that course. And then at the advanced level, they really go through sort of the full details of where to go to access the data, how to download the data, what all the variables within the specific data files mean. There gives some sort of code examples of how to plot specific things from those data sets. So those are really the focus of the advanced level courses. And those are usually tailored to specific data products. So for example, there's a training on tropomi. So looking at the data products from the tropomi instrument, it also covers some of the data products from the OMI instrument to highlight what the differences there are. There's also a course on the MODIS to VIIRS transition. So that goes through both the more historical, the MODIS data products and how those were used, and then the VIIRS data products and how those differ from the MODIS data products, and how to access and adapt, for example, things you were doing with the MODIS data products to now do with the VIIRS data products. So again, there's a lot of resources there, much more in-depth information if you want to try doing some of these things for yourself. Another resource I want to highlight was the Air Quality Data Pathfinder. This is a website and a tool put together by the Earth Science program to basically help people who have some fundamental understanding of satellite remote sensing, but are looking for maybe what specific data product out of all these acronyms I've been spitting out, what specific data product they really should be looking at for their needs. So it kind of tries to go from people's basic needs and direct them towards which specific data source they should be going to. And then finally, there's the Health and Air Quality Applied Science Team, or the HACAST program at NASA, which is basically connects researchers at NASA and at universities with who research satellite data and air quality with practitioners in air quality and in air quality management and in public health, and tries to use those teams to develop new ways of applying satellite data to solve health and air quality issues in the US and around the world. So they have a lot of useful resources on their website, examples of projects that they've done, some tutorials and guides for how to do some of these things that I've been talking about, as well as an online forum where you can go and pose questions and have folks from the HACAST team weigh in on them. So just to summarize some key takeaways, I think the points I want to emphasize are that satellite data can be a very useful tool, especially in terms of filling in the gaps in our understanding of air quality due to the relative lack of surface level monitoring in many cases. But however, there are a lot of limitations associated with using satellite data for this, because the satellites are not measuring air quality parameters that we typically deal with, like PM2.5 directly. They're being inferred indirectly from, for example, the effects that these are having on light passing through the air. So there's this indirect process of inference, which involves making assumptions and using models and making empirical relationships between the two, which can be useful, but it is, again, not a direct measurement. So you always have to take it with a little bit of caution. There are many free resources available. I touched at them briefly at the end to access and to visualize and to interpret, to some extent, satellite data and satellite-derived data sets. And for more training and guidance on these, I direct you to sort of the NASA Afri-Set program, the Applied Remote Sensing Training Program, for sort of more formalized training and lessons, and then to the HACAST project for maybe more informal interactions with experts working in this area. So with that, I'll thank you, and hopefully we have a little bit of time for some questions.